Hello everyone, I am Aayuj Asthana from Marwdi University of class TC1. I am studying computer engineering from Marwdi University. My topic for software component project is direct sequence spreading spectrum technique under the guidance of our Professor C.D. Burma sir, who is the HOD of ICT department. So what is spreading spectrum? This is an very important encoding method for wireless communications. It spreads data over wide bandwidth and makes jamming and interception very much harder for an intruder or an external person who's trying to breach the security of the signal sent by the user. There are basically two approaches and both are in use in these days. First one is frequency hopping spreading spectrum and the second one is direct sequence spreading spectrum. What are the advantages of spreading spectrum? It provides immunity from noise and multipart distortion, and it can hide or you can say encrypt the signals very well. So it is very important as a purpose for security. Several users can share same higher bandwidth with very much little interference, and it is mainly used in CDM or CDMA mobile telephones. So what is DSSS technique? In this technique, each bit of the signal sent by the user is represented by multiple bits of a spreading code. The spreading code can have 8 or 10 bits or n number of bits, it totally depends on the user. And this technique spreads the signal across a wider frequency band. And it has performance similar to the frequency hopping spreading spectrum. As you can see in this diagram, this is our signal data input A, this is our signal and this is our spreading code. So in this technique we will perform the XOR operation of the signal and the spreading code. And in the XOR operation, if both the bits are same, then it gives 0, otherwise 1. So through this XOR operation we obtain the signal, transmitted signal. Here it is C, which is called spreaded signal. And again we will do the XOR operation of transmitted signal and the spreading code, and it will give us back the signal sent by the user. So here comes our main part, the algorithm for the DSSS techniques program, C++ program. In the step 1, we are taking the input from the user, the signal, the first chip code and the second chip code. And through looping statements, we are performing the XOR operation of the signal and the first chip code, and the signal obtained is called spreaded signal. And in step 3, we are again performing the XOR operation of the first chip code with the spreaded signal, and we are getting back our signal in the binary form, which is same as sent by the user. In step 4, we are taking the second chip code and we are performing the XOR operation of the spreaded signal with the second chip code. And after this operation, we are getting a signal which is completely different from the signal sent by the user. Let's go to code blocks with where our C++ program is there. So this is our C++ program. This is our C++ program of DSSS technique. In this, I have taken 5 arrays, and through those arrays, I have stored the signal, the chip code, and the first chip code and the second chip code. I have displayed all the three signals on the console window. Here comes our main part, that is of spreaded signal. First I have taken the for loop for the signal, which will run from 0 to the length of the signal, and in that loop there is another for loop which will run from 0 to the length of the first chip code, and it will perform the XOR operation. As you know, in XOR operation, if both the bits are same, it will give 0, otherwise it will give 1. So if the condition of if is same, if both are same, then it will give 0, otherwise it will give 1. As you can see, else part is containing cout 1. So these two for loops are providing us the spreaded signal. Now comes our disparate signal. Here same work is happening. The loop is running from 0 to the length of the signal, and in that another for loop is running from 0 to the length of the first chip code, and same work is happening. Disparate signal. If both the bits are same, then it will give 0, otherwise it will give 1. Now we are disparaging the signal using another chip code. So here we are taking another chip code which is bit code 2 and the spread signal. If both are same, it will give 0, otherwise it will give 1. So this was our program. Let's head to the execution of this program. Suppose I give signal 101 and the chip code is I'm taking 6-bit chip code 110110 and another is 011011. So as you can see, spreaded signal is this, and we are performing XOR operation of spreaded signal and the chip code which is giving 101, which is same as the signal sent by the user. Another chip code is this, and the spreaded signal is using another chip code is this, which is not same sent by the user. We are taking another example. Let's run this program. Suppose signal is 100 and the chip code is 100100 and the another chip code is 011011. As you can see, this disparate signal is same 100 sent by the user, and the disparate signal using another chip code is 011, which is not same. Let's take another example. We are taking a third example as 1000 and chip code. I'm taking 4 bits of chip code 0011 and 1100. As you can see, disparate signal is 1000, which is same sent by the user, and disparate signal using another chip code is 0111, which is not same. So through this technique we can say that if we don't know the chip code, we cannot breach the security of the encoded signal. Now let's head back to our presentation. Here are some applications of this technique which is used in wireless applications, local area networks and wide area networks, and the stations use this technique for security purposes, as it cannot be jammed or intercepted by the malicious intruder. So this is very important in military operations. My learning outcomes used during completion of this project are very much, some of them are, I also learned how to implement the concepts of networking through coding, and I also learned how a signal is sent by a transmitter to a receiver without being decoded if the user doesn't know the security code. At the end, I would like to thank our HOD Professor C.D. Parmar sir for constantly guiding me towards the outcome of this project. Thank you, sir, for your valuable time in this project. Here are some references. The first one is Data Communication and Networking by Forozen, a 4th edition by Tata McGraw-Hill Publications. This is a very good book. If someone wants to read networking, he or she must prefer this book first. Here are some links, some Wikipedia, Telecom Back and Tutorials Point link, which are very helpful for understanding this technique. At the end, I would like to thank all of you for watching this video. Thank you.